Hello, welcome back to this exploration on building a DI container using TDD. On our previous screencast, we finished adding support for named services, and this one we'll start first looking at how we are handling errors on our container. The first thing is we want to see how we behave when we resolve services that have not been registered. Not registered. Close. And let's see what happens when we resolve the instance. Then resolve let's run that and see what happens. Okay, the exception we get is a key not found exception. Not very nice. So let's go and add a new exception type that colors can catch when this happens. So we'll have a resolution exception, and this is going to be a public exception. And what we want to have here is for now let's just leave it like that. And now we need to throw that exception from the resolve. So let's go back here, resolve implementation, and in our implementation here, when we look up at the factory by key, let's actually do it with a try get. So what we can do is if factories try get value for the key. So if we don't get the value out, then we throw a new resolution exception. Otherwise, we can cast this and invoke it. Now we can cast the actual factory object and invoke that here. Okay. So now if we go here, we can basically do an expected exception there, or we can just resolution exception, and if we don't throw a resolution exception, we can fail here. The reason I'm doing it this way is because the expected exception attribute here doesn't actually work on when you're using the compact framework unit testing and running it on the desktop. So I will keep it this way because that will make it easier when I have to port this to the compact framework. So let's run it, see if now it passes, and now it passed. So we're throwing the right exception. But now there's another scenario, which is I should be able to actually try resolve, not register, service returns null. So that's another thing. If I have a dependency which is optional, I should be able to do a try resolve and get a null back. So let's go and do the same, and this time instead of a try catch, we should have an API like that, and we can assert that is null for the foo. Okay. So let's add this functionality here. Try resolve for the foo, and let's go back to the container. We have the resolve results. We will need try resolve, and here we can basically reuse the implementation from the resolve implementation here, and we can just pass a boolean here at the end where we can say whether we want an exception to be thrown if the service is missing or not. So we can say this is bool throw if missing, and basically we can get the instance here, T service instance. Let's make it the default for the type. Alright, and then we can simply say that if this is the case and we have a throw if missing, then that's when we throw, otherwise we don't. So that would take care of that. Let's see if we don't have any bugs in here. If throw is missing, else return instance, and that's it. There we go. So now what we need to add is for all the results that are not, so this is try resolve, so this should false for the throw is missing, this should be true, this should be true, and this should be true because all the results should throw. Resolve name, this should also throw, and that's all. So now we can go back to here and get the null in that case. Very good. Let's run all the tests so far. See if we didn't break anything. Good. So of course, now that we have try resolve, we also should have try resolve for the overloads receiving also the constructor arguments, right? Just as we had for the resolve. So let's go and see if we can copy one of the existing ones, constructor argument on resolve. So we should be able to pass that also on the try resolve. There we go. Constructor argument passed on try resolve. And so we have register and try resolve here. So we also need to add the overloads for that. Let's go back to the container, and so we had resolve with the type of the arguments, and we'll basically have the same thing for the try resolve. So this would be a try resolve with the type of the argument, and in this case, because this is a try resolve, it's going to be false here. And the good thing is that because we have all the implementation in a single place in the resolve implementation here in the container, basically that's the only place where we are actually adding behavior at this point. So enough with arguments and types and try resolve nulls and the like. So let's get to something more interesting now. Let's add support for scoping the services so that they can be reused at the container level. So we had in the registration we have this API to give them names. So let's add also the behavior of adding the scope to the instance. And so one of the things we are going to need first is let's see how the API will look like. So first we will basically have instance is reused within container, right? So what we have now is sorry, another test, that bar builder, and let's see how we want this to shape up. Builder, register, bar, and let's not pass any constructor here. New bar 1, so that we know that this is the instance that it's going to be reused. Well, actually we don't need that, we just check for is same, and that should be the same. And now comes the name. We are not going to give it a name, but the API will going to be the same, so it's going to be something like reuse within, and then we define the scope. So we will need a scope. So let's go and add the reuse scope. This will be just an enum. So the behavior we have now is basically no reuse. Reuse scope dot container. So once we do that, and we get the container, resolve bar, we should basically be getting the same instance. So let's make an assertion for that. Are same v1 v2. So let's add this new member to the register, the registration. Sorry. Let's go back to the registration here, and this is our second member of the Fluent interface, and we'll polish the Fluent interface in a future screencast. We basically will have now one more property there, which will be the reuse scope. Let's call this scope. Let's call this scope. There we go. So now we have the test which can pass, but of course doesn't pass because we are not returning the same instance. So now if you go to the resolve functionality in the container, we'll see that basically here we are instantiating the object every time. So that's something we will need to basically improve. So we're invoking the factory every time. So now we're going to need to store a bit more than just the factory object in our dictionary. We'll actually want to keep the instances that we create, so that if they happen to be reused across the container, then we are going to reuse it. So what we will basically add is a service entry in the dictionary, and so now the service entry will have some more information. This can be internal, we don't need to make it public. And what we'll have is the factory that we were having now, and we will also have the actual instance that we create. Okay, and now our dictionary here will be a dictionary of service keys and service entries. So now these, instead of factories, can be renamed to services. Of course, the places where we were doing the register here, now we'll need to pass in a service entry here. So this will have to be service entry here, entry, and entry here. So let's back to the container builder, which is the one that is calling the registration, and here in the registration we are going to build the entry, service entry, and the service entry will have the factory as the registration factory. And now we can pass the entry here. Yeah, that one doesn't go there. Cool. So now that we are keeping service entries, now here is where we can go and check for the reuse scope. So let's take these out. Here we are going to retrieve the entry. So let's do this as services. Let's do a helper method there. Get entry, and for the key, get entry. Just so that we don't have to go casting here and there. We just keep it in a single place. So let's do object entry. Yeah, service entry. If services dot try get value key out entry. Actually, we can just do a try get value there and just return the entry. Yep, that makes the code a little cleaner here. And basically, what we had before, which was rather than this, we can just say if the entry is not null, we're going to do something. Otherwise, we have the code for throwing if the instance was missing. Okay? Otherwise, we will return a default value. Okay, so we are refactoring a little bit as we go along. Now let's see about the code inside here. So we got the entry. And the first thing is, let's say if the entry instance is equals to null, then it means that we need to create it. So let's see what the instance we need to return is going to be. We can make a switch here and say let's switch on the key dot. So how do we access the reuse scope? We're gonna need that information because that's the thing that tells us whether we actually will be reusing the instances or not. So obviously we'll need to add that information into the service entry. So this service entry will also have property with the reuse scope. Okay, and we will need to put that information in on the container builder. So in addition to the factory, we will need to say which is the scope, which will be the registration.scope. Okay. With that information, we can switch on the entry.scope. So if the scope is the container, well, if the scope is the container, then we can check if the entry.instance is null, then we can instantiate it here. And here is the code that we had before for invoking the factory. So let's go and paste that. We can basically cast the entry.factory to the type of the function. Remember we had before. Basically invoke that entry.instance is going to be the reinvoke there, and we can actually put this initializing variable, and we probably don't need that there. So let's do entry.instance and basically return the entry.instance. And we have to cast the instance, of course, to the type of the service. If the reuse is none, then we just go ahead and do the same thing here and just invoke the factory function. So we assign the instance to the entry, and we just do a return of the cast of the factory dot invoke invoking the factory. That would be okay. Wait, we need to do return invoker passing the funq of the entry dot factory. That's better. And if we don't get anything, then this should be another resolution exception because somebody passed in a scope which is not supported, and we'll put a message there. Actually, we can do it right now. Let's see. Let's go there, open the properties, resources. Let's do unknown scope, and let's see, unknown scope. That's it. Of course, that means we will need to add a constructor here with a message. We had a public one without anything before, so let's add one for the message, and this would call the base class message. Fine. So now what we have here is the two reuse scopes, and let's see if our test passes. Gone, green. So we have reuse at the container level, and we basically have to make sure that all the other tests pass, and probably there's a test missing for the reuse none. So let's go and see. Instance is not reused within container when we set the reuse to none. So this should be not the same. Perfect. Okay, so this is shaping up pretty well. We have support for scopes on the registration, so now we can reuse the instances. The next thing would be to polish up the Funq interface here. This is not very fluent at this point. If you do register, well, I mean, it is fluent because you can chain the calls, but that thing that you're getting properties mixed up with a lot of things, we're going to do that cleanup on the next screencast. But for now we have reuse of instances within a container. So stay tuned and see you on the next one.